presentation is go through a little extended response question focusing on the area of functions and graphs. And so what I've got here is George of the Jungle. He's got a hut that's located at point A, which is at 0, 2, and a river is close by and modelled by the curve y equals x cubed minus k. And notice where I've got x is bigger than or equal to 0, and k can be any positive real number. Now, there is a place on the riverbank that George is safe to bathe, which is located at B and is at a local village at point C. The first part of the question is that we need to find the coordinates of B and C in terms of K. So this is time to kick into our CAS. So as you can see, the first thing we need to do is open up a new document. And what I'll do is open up a notes page. Now the first thing we need to do is define the function. And so what we'll call, by pressing Control M, that will open up a maths box that we can now basically do anything mathematically in a maths box on a notes page. So we'll define f of x. So f of x, control, and then assign, and then we type in x cubed, so x to the power of 3 minus k, like so. And we press enter. We need to find the coordinates of B and C in terms of k. Now as you can see, B is located here. B is in fact the y-intercept of the graph, and C happens to be the x-intercept. Now it's important that we actually analyse that information carefully. Because that seems to give us a clue as to what we should do now in terms of a mathematical approach. Now if we want to work out the y-intercept first, we know that to find the y-intercept, x has to be 0. So what we will do then, if that's the case, is type in f of 0. So by pressing f of 0 in another maths box, you'll notice I'm in the maths box because it's highlighted by that red line. If I press enter now, I in fact get the y value that I require on the y-intercept. So now notice that is not a coordinate. To actually write the answer, we would actually write it as a coordinate, 0, negative k, surrounded in brackets. Now, as we've also worked out that the other point, which is point C, that there is actually the x-intercept. To find the x-intercept, we actually have to solve the equation f of x equals 0. Now to access solve, we press menu. You'll notice when we're using a notes page, the menu is a little bit different here. We need to go to calculations next, and then you'll actually be familiar with a lot of the calculator functions that you've seen before. Now if we go into option number 3, which is algebra, and number 1 is solve, we can now actually solve the equation f of x equals 0, and then don't forget to type in comma x to tell the calculator what variable that we are solving for. Now if we press enter, we now get the x coordinate of the intercept. But don't forget, we've got to actually write that down as a coordinate. Our answer must be a coordinate, so it would be k to the power of 1/3, comma 0. Now, I would actually also remind there's another way of actually, we don't necessarily have to use solve. There's a few different ways we could do this. Another command could be to use zeros instead. So where would we find zeros? It's under the algebra menu again. But as you can see, it's actually option number 4. Now, there is zeros does the same function as solving f of x equals 0, but all we actually have to do is type in f of x, comma, x. As you can see, it displays the answer as in a list instead, but it actually does perform the same function. The difference is, whatever expression we actually type in, it automatically makes it equal to 0. Now George decides after a while that it is not safe to bathe at point B, but finds point D located at MN. The direct distance he travels to this new hut is the same distance from A to B. So there's point D. So it's saying that the distance from A to B is the same as distance A to D, like so. First thing it says is to express the coordinate of D in terms of M and K. As we can see, D, the x-coordinate for D is actually M. So what we will now do, if that's the case, we're only allowed to express the coordinate in terms of M and K. And if I actually type in F of and ask the calculator to substitute M for X and press enter, we will now see that now the Y coordinate of D is expressed in terms of M and K. And so our answer now, because it does say to express it as a coordinate, would be the coordinate M, N cubed minus K. Remember, the question does say express the answer as a coordinate, so we must make sure we do answer the question. The next thing now it says, what is the distance from A to B in terms of K? So if we go back to here, from A to B we know that's a distance of 2. Down here we know that in fact that's a distance from here to here. That would be in fact the value of K if we understand how our cubic function has actually been translated along the y-axis. So the distance will be 2 plus K. And so if I go back over to here, and I'll actually type in that answer here, the distance from A to B is 2 plus K, to remind us that that is actually the answer. Now we might need that next, so what we will do is go back to the question. It now says that the distance from A to B is 4 kilometres. Find the value or values of K. Well, that would suggest, if I go back to our expression for K, 2 plus K, that actually has to equal 4. Now, I suppose we could, from a point of view of type, we could actually solve, if we press Control M, we could solve that. Solve 2 plus K equals 4, comma, and solve for K, and we'll get K equals 2. But I must admit, I'd like to think we would all be able to realise that that was in fact the answer. Now that we've done that, if we go back to the question, it now wants us to, for this value of K, find the coordinates of D. Alright? Now, if that's the case, what we should be able to do, if we go back to where D is, we know that this distance from A to B is the same distance from A to D. D is up there. So we know that that distance is in fact 4. So now what we're going to do is use the distance formula between 2 points to help us answer this question. But we're also going to solve the equation. And so what we're going to do is go solve the equation. The distance is 4 equals, now we go square root of, now it's going to be m take away 0 squared. Now we're probably wondering why is it m take away 0 squared, so I'll quickly flick back to the document. Remember the distance between 2 points, we have to first of all subtract the x-coordinates, the difference between the x-coordinates. So the difference of this x-coordinate is m, this x-coordinate is 0, so it's m take away 0, and we have to square that result. And then it's going to be the same thing for the y values. So we go plus, now the y value, remember, is f of m minus 2. So remember, the y value is worked out in terms of m by substituting m into the function, and then we're subtracting the y value 2, which is on the axis. And then don't forget we need to square that result. So just have a close look at that. The distance we were told was 4 equals the square root of the distance between the two x-coordinates and the difference between the two y-coordinates. Now, the only thing we actually haven't taken into account here is the fact that we actually have to remember we are solving for m, because we want to find the value of m. And if I press enter, something interesting will happen. You'll notice that the answer is in fact all in terms of k. That's because remember the function is still got k as a variable, but we realise that k is actually 2. So to get around that, if I put my cursor at the end of that last bracket and then type given k equals 2, because we know that that is true, if I now press enter, I now actually get the answers. Now notice there is a number of answers here, so we've got to be a little bit careful as to which it in fact may be. So if we go back to our diagram, m equals 0, so that's a value of x. That would make a little bit of sense. That's actually a distance of 4 there. It is also saying that if we go back here, that m could be 0.12, so just a little bit more than 0. So if I go back to my diagram, that would be over here somewhere, so that would suggest that that's also 4, about here somewhere. But, as you can see, D is up here, and so if we actually have a look at our last answer, m being 1.956, that is in fact the answer that we're after. Now, of course, we're after the coordinate of D, which means what we need to now is work out f of. Now what I'm going to do is copy that whole answer, go Control C, and then Control V, close the bracket and press enter. Oops, and I've run into the same trouble. As you can see, I have not taken into consideration the fact that I've got K. So I need to, don't forget to go given K equals 2. Of course, what we could do is actually put K equals 2 initially into the function, and that would solve this issue about having to put given K equals 2. And we've got the corresponding Y value. Don't forget, the answer does say coordinate, so make sure we express the answer as a coordinate. Now we'll go back to the question. Okay. For this value of K, find the coordinates of D if it was to be located, so the distance that George has to travel or has to walk is a minimum. So now what the question is saying, alright, he doesn't want to travel as far as he needs to, so he wants to minimise how far he needs to travel, and so D has to be relocated. So now we're looking at the minimum possible distance. Right, so what I'm going to do to actually help answer this question is I'm going to insert a new problem. Oops, what I'll do is I'll do it on the screen here. If we press Doc and insert a new problem, a new notes page. What I'll now do is open up a maths box and define the function that we're using. But this time what I'll do is put in the value of K. So f of x equals x cubed minus 2. Okay, now what we need to do is work out the minimum distance. So I'm going to now define a distance formula. We'll call it distance, or dist, as a function of x, and assign that to the square root of, and again, remember now, we're talking about the difference between the x coordinates, and so this is going to be x minus 0, all squared, because you're working at the distance, or the difference between the x coordinate at D and the point A, which is 0, plus, now we're working at the difference between the y coordinates. The y coordinates are worked out at D by the y value of f of x, and then we are then subtracting 2 from that, because that's the y coordinate at point A. So that's squared. If I press enter, it's done. Now if I actually type in, or if I won't type it in, probably when you're using a handheld, it'd be a good idea to hit the var button. As you can see, there's the variable distance as a function of x. We just type that in. If I press that, it actually gives us the function. Now what we need to do is differentiate that. So if I actually access my template and access the derivative template, so we're differentiating with respect to x, the function distance with respect to x, there's the derivative. Now remember, to find the minimum distance, the derivative actually has to equal to 0. So what we could do is copy all that, Control C, and what I'm going to do now is solve that equaling to 0. So menu, calculations, calculus, algebra, and solve. Control V, so there is the derivative. We make that equal to 0, and don't forget to press comma x to tell the calculator that we are solving for x. Now when we press enter, we get some answers. X equals 0, 0.08, and 1.53. 1.55859. So again, we've got some choices to make as to which, in fact, this could be. Which one is it? What we could do is actually open up a graphs page. So if I press Control, so Control I is a quick way to insert a page within a problem. If I go to graphs page, we can in fact look at the function of distance in terms of x, and we get that particular cool looking graph. Now remember, we're trying to look at the minimum distance, and so you can see there's a stationary point of 0 occurring here, but this is the one we want because this is the local minimum here. Alright, and so if we go back to our answers on the previous page, it can only be the one, which is the 1.55895. So that's the x value. Right, but don't forget, we need to now substitute that. So we press F of, then we highlight that, and then Control C, Control V, press enter, and we get the corresponding y coordinate. Now notice that I did actually put that, I'm wanting the coordinate. I did not put that in the distance function, because that's actually calculating the length of the line, straight line he has to travel, the distance he has to walk. The last question does actually ask us to, oh, there it is, work out the minimum distance that George would actually have to travel. And so that would mean now that we turn around and get our answer, which is the 1.55859, and we're going to put that into the distance rule. And then we'll go Control V again, press enter, and we've got the minimum distance calculated. That could be confirmed if I go back to here. Back to, in fact, whoops, I'll actually insert Control I. I'll insert another graphs page. And if I type in f of x, we get our graph up of the river. And what I'll do is, if I go through menu, geometry, points and lines, and point on, I'm going to put a point on the curve. Oops, point on, and then press enter, and it will stay there. I'm also going to put a point on where point A is located. Let escape. Now what I'll do is I'll join those up with a line. So geometry, points and lines, and draw a line segment joining that and that. Those 2 points up. Now, if I now type in, if I go back to here, to my answer on this screen, and grab that, and go Control C, and put that into here, copy that into there on the X coordinate and press enter, you'll see now that there is the distance that he has to travel, the length along that line there from point A to point D. And if I go through menu, geometry, and measurement, and measure the length from there to there, I get the length that I calculated using the calculus. And the only thing I can show you now is, we're wondering, would that be the minimum length? If I actually grab that point and then move it up or down, you can see that either side of that, again, it starts to increase. So we can be confident that that's all good to go. And that brings to the conclusion my little extended response question on this area of study.